Hello and welcome to the video lecture, which is the substitute for the missed class on January 19th, 2016. The purpose of this class, semi-class, virtual class, is to go over homework number 1. Homework number 1 is foundational for this course. Some of the skills you will end up using in further problem solving. Certainly all of the concepts and approaches to problem solving are things that you will be using throughout. So I've written out some answers ahead of time and we'll be going through each one individually with some explanation. My intention is to stop between problems and post each of those problems as a separate video segment. And look, you get to see my piece of paper and my handwriting and not my face, which is probably a good thing for everybody. Anyhow, problem number 1, a car starts from rest and heads east at a constant 12 meters per second. That's a velocity, by the way. How far has it gone after 1 second, 2 seconds, 5 seconds, and 10 seconds? And finally, how fast is it going at 10 seconds? Notice that velocity, the speed, is constant. We don't talk at all about direction in this problem, but in general we will be talking about speeds as a velocity with the direction implicit. Because we have defined the direction as east, that enables us to incorporate direction into that speed, which is the magnitude of the velocity vector. Using the approach we talked about in class, current position is original position plus the change in position, or in equation language, x equals x sub 0, that notation meaning the original or initial condition, plus v times t. V is velocity, t is time. We're taking x sub 0 to be 0. That enables us in all of our further calculations to have x sub 0 drop out of the equation. So for that first calculation at 1 second of time, notice please that I'm being very explicit with my units to make sure that everything checks out. Being explicit with your units is a good practice to get into, because that is going to be your first approach to noticing that you have made a mistake in how you've set something up. So position is equal to original position, which is 0, plus velocity times the time elapsed for 12 meters. Note that seconds in the numerator above the line and seconds below the line in the denominator cancel out, leaving us with the unit meters, which is the correct and expected unit for a position. This is 12 meters, of course, from the starting position. That would look something like this. Starting position, direction is eastward, and that would be 12 meters. At the end of 2 seconds, of course, we've gone 24 meters. Nothing surprising there, 60 meters by the end of 5 seconds, etc. I should note that some of you may have been tempted to take the answer from the previous problem and feed it in as the initial position in the subsequent problem. That is perfectly okay, but in order to do that, you need to be careful about what the elapsed time is between those two positions. If, for instance, for part B, you fed the new initial position at 12 meters in for x sub 0, then you would need to use the elapsed time, 2 seconds, minus the 1 second that has already happened here, as the time input in that equation. Not a big deal here, more of a big deal for these later equations. It's a good practice to just go ahead for these sort of sequential problems, to just go ahead and always go back to what's going on from the starting position and the starting time, t equals 0, rather than doing something crazy and iterative where you might slip up in how much time has actually elapsed. The final question is, of course, how fast is it going at 10 seconds? That seems like a trick question, but is relevant for later problems. The velocity, of course, remains constant at 12 meters per second.